Okay, guys, we're going to go through the cam on the Lego real quick. So first thing you want to do, you'll be on the design tab up here. You want to switch that over to the manufacture tab. And always the first thing, when you're in the manufacture tab, you're going to have to do a setup. So I'm going to do a setup of this. And I went and measured my block. I went and found one under stock here. We go fixed size box. Mine is 5.5. Oops. By 2.234 by 1.25. So yours will be a little different than that. That's mine is. I'm gonna go ahead and rotate it over to the front here. Change my model position from centered on the Z here to centered from the top. And the offset distance will be 0.0. I can go 0.03. So we got 30 thousandths on the top here to face off. I'm gonna come back to setup. I'm gonna take my origin and I'm actually gonna move it to the bottom corner here. Not that corner, sorry. This corner. And I'm gonna flip my Z because we're gonna start on the bottom for the sake of, I think if we were to machine these lugs out, it's gonna have a hard time sitting on parallel bars. I don't think I have enough width here. So we'll machine this side, parallel bars will sit right here. Then we'll flip it over and we'll machine the other side. So my origin's going the right way, X to the right, Y back, Z up. Say okay to that. Oops. And before we get started, we want to go ahead and make a new tool because we have a tool that we don't have in the tool library yet, and I want to show you guys kind of the process of editing those tools. So I'm just going to come up here to tool library, come in here to my mill tools, and I'm going to click this plus button right here. And we're going to make a flat end mill, cutter, flat end mill, unit is inches, clock guards rotation, number of flutes. That's these flutes on there. This one has 4 on it. The material is carbide. The diameter is 0.1875. It's 3/16 of an inch. Shaft diameter is 0.1875. Overall length, let me go and measure that. I believe it's 2.5. Yeah. 2.5. Length below holder. Let's just say we're going to stick it out 1.25 inches. Shoulder length, this one doesn't have a shoulder on it, so I'm just going to leave it at that 0.875. And then the flute length, this number is really super important because it's the number, or it's the depth you can take in a cut. And on this one it is 0.5. So if you go any deeper than that, Fusion will recognize, hey, you can't cut more than that. You can't cut deeper than that because you don't have any flute. So if you're making a new tool, make sure you're measuring this flute and inputting that number and stuff. Cutting data, we'll go ahead and run this at 7,000 RPM. We'll feed at Let's feed at 60 inches a minute with that. 60. Lead in and lead out. Let's slow those down to 40. Transition, we can run at 40. Yeah, we'll run at 40. And plunge, we plunge at 40. So that's what all those numbers look like. Use step over. I'm going to turn that on. Check that. And so this is like each pass it takes in a cut, how far over the tool is going to step each pass. And let's go ahead and set that to, let's set it to 30 thousandths. Flood coolant, we do want that to come on. And that's it. So we're just going to click accept to that. And that's going to make a new 3/16 flat end mill tool. The nice thing about editing these is every time I pull this 3/16 inch flat end mill, it is going to reference this cutting data in that tool path. So I'm not going to have to input all this information each time. So what we can do is we can go into let's go into the 3-inch face mill. We'll go to cutting data, and I'm just going to leave this up real quick. Go ahead and adjust your numbers. So your spindle speed will be 7,000, your ramp spindle speed will be 7,000, cutting feed rate will be 100, lead in, lead out will be 100, transition will be 100, ramp will be 50, plunge will be 50. And then I check this use step downs box. My step down distance will be 50 thousandths. You step over, and that will be 1.5 inches. And then I just go ahead and disable the coolant. So anytime I'm using the face mill, these will be the defaults that it uses. Then the other one is a 1/2 inch flat end mill. I can't remember off the top of my head if I've made this tool for you guys or not. If I haven't, go ahead and make a new tool, and I will flip through. So this is the information you want. You just pause the video and edit that cutting data. This is the data you want. You want to use a step over of 50 thousandths, and I leave the flood coolant on. I'm going to go ahead and close out of there. So first thing we're going to do a facing tool path. So I'm just going to do a face, select the tool, 3-inch face mill, select that. And you can see if you edited your numbers, those will pull in for you. We disabled the coolant, so that's automatically disabled. Geometry, it's going to face everything. Heights, we want to start from the top of the stock top, and we want to face down to the model top. And so if we rotate those to the side, you can see we have a little bit of stock up here, so it's going to start doing transition moves and stuff up here, and it's going to face down to this dark blue line, which is the top of our model, which is good. That is what we want. Passes, pass extension height. I'm going to increase this just a little bit because we have a 3-inch face mill. Off the center of that, it's an 1.5 inch radius, so it's going to extend out half that 1.5 inches. And I want it to come out a little bit further just for safety reasons. So I'm going to go 1.75. On that, the step over, we set that to 1.5 inches when we edited the tool. And then if you were to use multiple depths, it's going to default to that 50 thousandths that we set when we edited the tool. But for this, since we only have 30 thousandths here, we don't need multiple depths on. Linking, that's all going to be good. And that looks good. It's going to come in, take a cut, take another cut. Let's do 2D adaptive with that 3/16 end mill that we made. Check all your defaults, make sure they look good, because sometimes they don't. Like that one right there. What? Yeah, it's good just to run through these and just double check them. Geometry. So we want it to mill out this whole pocket here. And typically I would click this and then click like the bottom of these circles, but it looks like it's not going to let me click the bottom of the circles. So I'm just going to exit out of those, and I'm just going to click that. I know I'm going to be able to click the top edge of the circle here. Top edge, just like that. And our arrows are on the right side because we want it to, on this outside one, the arrow's on the inside. If we flip that, it would try and cut everything on the outside of that. But we want that on the inside. Same with these. If we were to flip them, it's going to cut everything in here. But we want it to leave those. So we're going to leave the arrows on the outside. Heights. We're going to set these to model top. The only reason you could set them to stock top, but the only reason I am not, let me rotate it over so you can see. So we could change these to stock top, and you'll see this orange one move up a little bit. We don't need them to be at stock top because we've already faced that stock off. So there's nothing up here to hit anymore because that facing toolpath took care of that. And then our bottom height. So we selected the top edge here. So it's going to default to selected contours, but if we leave it on that, it's not going to cut anything. So what I'm going to do is I'm going to go down here to selection, and I'm just going to click on the bottom of the pocket there. Passes, optimal load, we set our default to 30 thousandths, so that's good. Stock to leave. We don't want to leave any axial stock, but we do want to leave some radial stock. So axial stock versus radial stock. Axial stock would leave stock on the bottom of this pocket. Radial stock is going to leave stock on like the walls of the pocket. And 2D adaptive toolpaths are really good roughing toolpaths, but they're absolutely garbage finishing toolpaths. They're going to leave little scallops on the walls. So I usually leave about 20 thousandths so I can come back and do a 2D contour to clean that up. Linking, stay down. Let's turn that up to 80%, and it can helix, and that's okay. So let's see okay to that. See what that looks like. So it's helixing in out here. Yep, it's coming through here all right. That all looks good. It's coming above the part when it's transitioning here. Okay. Yeah, that looks good. Now let's do a 2D contour. We'll do the same thing. And actually, rather than inputting all that stuff again, let's just right click on 2D adaptive. We're going to create a derived operation, 2D milling, 2D contour. And I'm just going to say okay to that and see what it looks like. All our transitions look good. Let's go double check it real quick. So typically if you do that, it'll spit out a pretty good toolpath, but I always go in and check it just in case. That looks good. Selection face. Finish feed rate. Yeah, we could leave that at 100. That'll be okay. And then you can use, yep, that all looks good. Now we need to 2D adapt to the outside and 2D contour the outside. So similar process. I'm just going to steal from this one again. Create derived operation, 2D milling, 2D adaptive clearing. I'm going to come to geometry. I'm going to get rid of those. I'm going to say I want that as my geometry because I want it to rough out all that. Come back to my tool. Select a 1/2 inch flat end mill. Check all my numbers, 7,000, 7,000, 100, 100, 100, 100, 50, 50. Those look good. Heights. We're going to start from the top of the model. Bottom height, I'm going to get rid of selection. And we're going to go to the... Actually, we can leave that on. Selection, and we'll select down there. If you rotate it over to the side, it should come down to that bottom edge. And we're going to offset that negative 0.03. So our end mill for sure cuts all this material. Yeah, 30,000 is good. Passes. Optimal load. Let's make sure that's at the 50 thousandths. Stock to leave. Radially, we're going to leave 20. Stay down distance should be set to 80% already. We're going to say OK to that. So come in, rough that out. That looks good. We'll do the same thing. Create a derived operation, 2D milling, 2D contour. Let's just check this real quick while we're here. Close chain, that looks good. Heights, come at 30 thousandths below are selected. We don't have roughing passes or multiple depths. See that left on, good. And that looks good. So let's go ahead and right click, simulate it. See what that looks like. Looking good. And as you're watching these simulations, it'll show you what toolpath you're on right here. So next, I'm going to go down to the 2D contour, which it should just kind of work its way around the part and clean it up. Let's see what that looks like. Cleans it up all the way into my line. And one thing to keep an eye on too is as when you have a end mill coming into a corner. When you have an end mill coming into a corner of a part, you don't want to, absolutely don't want to have the end mill radius match the radius that you drew. That will break an end mill almost every time. So that's why I chose a little bit smaller end mill to come in and clean that out, because it doesn't spike the spindle load when it goes into the corner. That all looks good. Finish inch is that? Half inch comes around and roughs it out. Looks good, looks good. We've got kind of verifying I've got enough material down here to hold in my vise. That looks good. The 2D contour around. Good, awesome. Let's exit the simulation. Now we can flip this and do the other side. So I'm going to go ahead and create another setup for stock. I'm going to set this to from preceding setup because I don't want to have to go through and set that whole thing up again. So what that's going to do is it's going to look at my stock and it's going to say, okay, there is 30 thousandths that was on the bottom here. So therefore there's this much on the top for setup. When we flip this, our origin, rather than stock box point, we're going to model box point. We're going to go on this back corner here. X is going to the right, Y is going back, Z is going up. That is how it should be. That all looks good. Let's say okay to that. And on this one, let's go ahead and start with the face mill. We'll face it off down to the top of these, and we'll come around with an end mill and clean those up. So I'll face with a 3-inch face mill. Geometry, it's going to do everything. Heights, stock top, stock top, stock top. Down to the top of the model, which on this should be the top of these lugs. It might be a little more obvious on this one. So if I change this from stock top to model top, the top of the stock starts up here somewhere. You can't see it. But that's the difference between those. So it's taking into account the stock distance that's here. You can't see it. So it's just going to face from the top of the stock to the top of the model. These ones, I don't want to say you can kind of ignore them, but set them to whatever you set this one to. And like on this, we have stock, so we need to start from the top of the stock and go down to the top of the model. Under passes tab, we have a lot of material here, so we're going to check multiple depths. Linking, that all looks good. Tool, I just wanted to make sure I had my coolant off. That looks good. So it's going to come take a couple cuts, get it down so you can see the top of the lug. And let's do a 2D adaptive with a 3/16 flat end mill. I want it to come to do everything. Everything but those. Heights. Since we have faced off the stock, we can go from the top of the model, top of the model, top of the model, to selection, with that being our selection right there. Offset, we're going to leave it at 0. Passes, optimal load should be 30 thousandths. Stock to leave, like I said before. Axial, we're going to turn down to 0. Radial, we'll leave it at 20. I believe it should be able to fit through there like that, like between these gaps. But we will see. Stay down level, 80%. Helix, that's fine. That's okay. Let that generate. Oh yeah, I was able to get in there. And easy. Looks good. Let's do a derived operation, 2D milling, 2D contour. Oh, darn it. I didn't check my numbers on the last one. So let's go through. We need to remember to go back to this adaptive and change the cutting feed rate to 100. Geometry, that looks good. So it's just going to come face around those, or contour around them. Heights, that all looks good. Passes, that all looks good. I don't have roughing, multiple depths on. And that looks good. It's okay with that. Come into the adaptive before I forget. Set to 100 inches a minute. It's okay. Go into the tool library before I forget and see why this is doing this. 3/16, cutting data. That would be why that is doing that. Let's accept that. Exit out of here. And the last thing, actually, let's go back. We'll activate setup. This is actually setup 1. We'll activate it because we want to edit that. Let's go do a chamfer around this whole thing. So let's go into 2D chamfer. For the tool, we will use our spot drill, 90-degree spot drill. Spindle speed 7,000. Cutting feed rate, that's feed at 50 inches a minute. 50, 50, 50, 50. Ramp, we'll ramp at 25. Not 25. 25. Plunge at 25. Track to 25. Geometry, we want to chamfer that. Chamfer that. We want to chamfer these. Heights, yep, those all look good. Model top. Passes, chamfer width. Let's make that let's make it 5,000s. That all looks good. Yep. It's going to go around, put a tiny little itty bitty chamfer on there. On that side. And then let's flip this over. Activate this one. And let's do the same thing. 2D chamfer. Select, it's already got the spot drill, I think. Let's do spot drill. 7,000 RPM. 50. 25. Geometry, we want to chamfer that. We want to chamfer these. Yep. Yeah. Don't want to chamfer the face. I'm going to click the X right here. Gotta get rid of that face. Chamfer all that. Heights, we want to start from the top of the model. Bottom height is our selected contours that we clicked on. Passes, chamfer width. Let's make those 5,000s too. Chamfer tip offset. We can leave that where it is. Thinking, leave that all on. Yep, take care of that. And let's go ahead and simulate both these together. So I'm just going to click on up one, push shift on my keyboard to click on up two, right click, and simulate. I'm going to go through these ones a little bit faster until I get to that chamfer, because I know these are good. Oop, go back. Go back. Well, chamfer looks good. It's clearing everything. Then I'll usually zoom in. Zoom in and check the chamfer size. That looks good. Speed up the face here a little bit. So it's cutting. One good thing to check here is to make sure as we're cutting, the end mill is sticking down below the surface a little bit. And then also when it's done cutting, it should leave just a little bit of material that axial stock, I believe we had it set to 20,000, so it should leave. Oh no, it won't leave 20,000 on this quilt because it's going to face in and go all the way into the lugs. Oh wait, we might have to go change something on that one. So let's speed this up a little bit. Good. Good. Chamfers. We're done. Exit simulation. Let's go into Op2 Lego Adaptive. Edit that. Let's go to heights. Okay, so the bottom height. Yep, that's pretty good there. I thought I had an offset distance in here. That looks good. Check the contour one more time. That looks good too. Okay, yeah, that's it for this. You're ready to post this out and go cut them out.